Calc BC, we're back in lesson 6.2, finishing up example 3. So we're revolving around another line. That's so classic of a question on the AP exam. If you're going to deal with the disk method, it's 90% some likely that you're going to have to revolve around a line like y equals 4, y equals -2, or something like that. The disk method, what you're going to see though is your region doesn't have any space. It goes flush up right against. You can see this yellow is touching the y equals 4. So what do you have to do? Well, go to the line that you're revolving about, this y equals 4. Make a rectangle perpendicular to that axis. In other words, the base of your rectangle will actually be touching and will be on that line. And you can see what's just happened. As you're looking here, this rectangle is very typical of what you've been seeing in the past chapters. We did Riemann sums. We're going to build our rectangles from x equals -2 to x equals +2. We're going in an x direction. And then what? Well, we're going to have pi, and we're going to have our radius squared. But we're always going to do, here we go again, top minus bottom. What is your top boundary? Well, your top boundary is this y equals 4. How about your bottom boundary? That's your parabola, your x squared. And guys, it's at this point where we're just going to speed up the process. Obviously, we could expand this. Obviously, just FOIL that out and, do the fundamental theorem. That being said, if we are really just focusing in on the important task of how to set this up, we're going to be good enough to just get this typed out. I'm leaving the pi out. We'll put the pi in the end. So we'll have 4 minus x squared, that whole thing squared. That's the length of your rectangle, the height of your rectangle. It's really your radius, isn't it? And here's your dx. And as you work that out, 34.133, we can hit math frac. 512 over 15. But guess what? There's a pi in there. So that's what your volume would really be represented as. Let's take a look at what happens when we revolve with space. Let's just say your region is like from what we saw in 6.1. It's the area between two curves. But if you were to revolve around, say, the x-axis, there is space between that region and the axis. So what happens as you revolve that is there will be a hollowed out section in between that region and the x-axis. Likewise for the volume, it will be hollowed out. Now, this is going to require us to use a new method. It's going to be the washer method. You might wonder why in the world we're calling that the washer method. Here's why. If we were to take a rectangle, again, perpendicular, taking our big radius here, and then if we had a little radius in blue, see, look what we've got. We've got our big radius. Right, that is a big capital R. Then in blue right here, we'll have our little radius. That's right over here. If you were to subtract, you could see that you'd actually wind up with this little portion inside in green. And that's what they're dealing with right here. So that's honestly what we are headed towards. But this washer method, we have to be so careful. There are some huge misconceptions with the washer method. We're really using the disk method twice. It's like taking your big radius, finding the volume all the way solid, and then subtracting this blank volume that would also, it's like a takeaway problem. So it's the disk method twice. This is called the washer method. It's when you see space. So like I said, it's the disk method with the big radius. Take away the space, take away your little radius, and that's effectively what's going to happen. Now, what you can do is pull the pi's out and join these integrals into one. And what you're seeing right here is very typical of what you'd see in a textbook. You look inside and you could say, well, I've got my big radius, I've got my small radius right here. And not surprisingly, there is a huge misunderstanding. Notice I put triple stars here. This is not the same thing as pi from a to b of f minus g and then squaring. You don't get the same thing. That would be a very different scenario if you were writing that out. And that's the number one mistake with the disk method, where students want to do f minus g and then square that whole thing. So be careful. It's really just f squared minus g squared, not squaring the subtraction. We can talk more about that in class if we need further clarification. You don't get the same answer doing this method that we crossed out. All right, so take a look at a couple of problems here. Let's see if we can do a problem together. We've got y equals x, the identity function. Here's y equals x. And this thing right here, if we had x plus y equals 4, this thing right here is really y equals negative x plus 4, and that would have a y-intercept of 4. Actually, it would also have an x-intercept of 4 if you think about it that way. Wow, look at that. And you'd have this line going just like so. Obviously, we're going to get an intersection right there. So very often kids will wonder, hey, do I need to solve algebraically? And you could plug in y equals x right here and get x plus x is equal to 4. You could get 2x is equal to 4, and x would equal 2. And then you could get y is equal to 2 also. Here's the point 2 comma 2. But guys, please realize you could also solve by inspection. If you'd say, x plus y equals 4, it kind of looks like it might be 2 comma 2. You could try it and see if you get it. You do, in fact, luck out. Here's x equals 0. That's actually the y-axis, isn't it? And right now, if you're looking here, you could see, thankfully, we have this enclosed region, don't we? We have this little triangle. And we're going to revolve around the x-axis. Well, at this point, you could hopefully see that, my goodness, we have space between this yellow triangle region and the x-axis. We're going to need the washer method. Go to the axis that you have. You're going to have your little radius right here. And, then you're going to have a big radius. You can have that one too. You can draw that up. Doesn't matter which color you're using. You've got your big radius. You've got your little radius. And you can see what's happening as soon as you draw the rectangles there. You can see that you're stacking left to right. So as you're stacking those left to right, you're going to be integrating in terms of x. So you're going to integrate between 0 and 2. And I'm going to pull out a pi. But I want to have a big radius minus a little radius. But they're going to be squared. The big radius, do top minus bottom. What's this top equation? Well, it's y equals negative x plus 4. So I'm going to go negative x plus 4 minus, well, what's the bottom of this rectangle? Well, it's y equals 0. It's the x-axis. So we're going to square that. Then we're going to have our little radius. That's y equals x for the top minus y equals 0 on the bottom. And guys, right here, we're practically done. All you got to do right now is get some assistance from the calculator. We're going to integrate between 0 and 2. The minus 0, of course, is going to just really go away in this regard. Likewise, x minus 0 is just an x. Could we work this out by hand? Most definitely we could. But let's see where we're going. We'll say math. Bring this up here. Here's your fn int. We're going to go between 0 and 2. Put in some parentheses here. We'll say negative x plus 4. And then we square that. I'm going to say minus an x squared. And guess what? You work this out. Don't forget there is a pi in this answer. You're going to get 16 pi. Okay? So when you see that space, that's really where we're going. There is only one last problem remaining. But here we go again. This is very typical of what the AP is going to give you. Guys, you're not going to be given problems where you're revolving around the x and y axis as much on an AP exam. Look at this. You've got y equals x squared. That's your basic parabola. You've got y equals 4. That's right over here. And then we're revolving around this line, x equals 2. Now, by the way, if you set x squared equal to 4, I think kids quickly are going to realize that we're going to have intersections at negative 2 and positive 2. So it doesn't take you too long for kids to see that here's this line, x equals 2, and we're going to be rotating, revolving around it. Wow. So look at this. This point down here is 0, 0. This point over here is negative 2, 4. This point up here is 2, 4. And let's shade in what we've got right here. Here's this region. But guys, this time there is space between this yellow region and where we're revolving. There's space. We know we're going to have to use the washer method. Tell you what, I'm going to very quickly draw in my radii. I have to go from the axis, change of color here, from the axis and come out over here. Here's my little r. That's a little rectangle, isn't it? And then you can think, well, now we're going to need a big rectangle. Well, that's going to go the further distance away. How do you know what you're dealing with? Well, the big radius is always the radius that is going to have more distance. Okay, so we've got our little r, we've got our big R. What I hope is going to be very clear to you is that we're integrating not in terms of x, but in terms of y. When you're seeing these rectangles, they're stacked going up and down. So I've got y equals 0 to y equals 4, and we're going to have a dy. I'm going to pull a pi out. We'll have our big R minus our little r. The big R, we're going to have to do right minus left. So look at this. The right boundary is x equals 2. How about the left boundary? The left boundary, be careful. This x squared is equal to y. I need to solve for x. If I take my square roots, I'll have x is equal to plus or minus radical y. Over in this second quadrant, that's where x is equal to negative radical y. In the positive first quadrant, x is equal to positive radical y. So I'll have right minus left. I'll have x equals 2 for my right boundary. The other one is